Cool. Hi, everybody. My name is Faazil Shaikh, and today I'm going to talk about centralized log management and Crato, a project that I built with two. Oh, speak up. Hello. Yeah. Oh, is it on? It's on. Yeah. A little closer. Is that better? It's like really quick. Okay. So yeah, I'm going to talk about centralized log management and Crato, a project that I built with two developer friends. Cool. So yeah, first of all, what is Crato? It's an open source centralized log management framework for small web applications to have a central log management solution, and designed for easy deployment and to maintain high ownership of their data. But before we even go ahead and talk about Crato, we're going to talk about some other stuff first. And just to cover our agenda today, we're going to talk about what is logging, why it matters for small applications, the current solution space, Crato's design and use and where it fits in the solution space, and how it's implemented. So first of all, what is a log? Well, typically we just know a log as a file. So in a standalone machine, there's various apps, systems, services, daemons, and they're all producing log messages by way of a logging system running in the background known as syslog. And we'll dive into syslog in a bit. But yeah, these log messages are collected and they're written to a file in the var log directory. And yeah, the file name is depending on, the service or daemon, like it's, Apache web server, it might be an access log, or if it's a database, it might be a MySQL log file. So logs as files are one way to think of them, but we can think of a log as a file as a form of a data structure. And as J. Krebs concisely defined it, a log is a structured append-only array of records. So J. Krebs, he is co-founder of Confluent. He was a former LinkedIn engineer, founded the Kafka messaging system, and he authored a lot of these ideas about logs and streaming, and wrote a book called I Heart Logs, which I came to heart as well when researching and building this project. So looking at this log as a data structure, we'll notice a couple of things. We'll notice that we start to read it from left to right because naturally it's the oldest record to the newest. So with that, there's this notion of time. And yeah, that ordering gives it a natural notion of time because it's append only. And when we think of a log as a file, we think of it as something static. Typically, when we're working with logs, a common way that we work with them is using the grep command line utility. And one example of this is here we're grepping for logs that came in within a 10-minute period. So in this example, we see logs as, something static possibly. But logs can also be thought of as a stream of data. So essentially, J. Krebs also espouses that log is another word for stream, and logs are at the heart of stream processing. So when we use the tail command line utility instead, we can see how these log messages are coming in, and it's when we look at it here, we see essentially an endless stream with no necessary beginning or end. And when we think about it as a stream, we can kind of redirect it and split it up for our own processing purposes. So why are these properties important? So logs are streams of events that capture the history of our application. They essentially capture change. They record what happened and when, and we can think of it as an alternative source of truth to a database. And underscoring this idea further is what's known as the stream table duality, and it's another idea that's espoused by J. Krebs and people like Martin Kleppmann. And the stream table duality is just a way of thinking of data in two related but separate forms. So the first way is as a table. And in this example, we can see we'll see two users exchanging money between themselves. And what we'll notice is that the data is for a table is mutable, and it's changing each time they exchange money. So the ending balance for Big Ed is 250, and for Paul Bunyan it's 50. And we notice that the data is mutable here. What this tells us is that that tables can tell us about the present, but there's multiple ways to get from one point to another, and a table doesn't necessarily tell us about that, which is why we might want to look at a changelog, and that's where streams come in. So here, because a changelog and streams are append only, they're powerful in that they capture change. And with a stream, it's powerful because we can essentially create a snapshot of any point in time in our history, and not just see the present like with a table. So yeah, sometimes you don't want to know what changed, you just want to know why or how it changed. So streams, aggregating over them, you can recreate a table, and this event data allows you to create a snapshot of any point in time, which a table doesn't necessarily allow you to do. So related to that, why does logging matter for small applications? So logging matters because with this historical event data, you can, like we talked about, reflect any point in time, which you can't necessarily do with a table. And of course, this historical data has business value and developer value, finding trends, patterns, and behaviors for analysis purposes. Also, sometimes you just need to record logs out of necessity, like for you might need to have audit logs. And it also matters because this log data is being lost by the second. This data isn't stored on a system indefinitely. There's processes running in the background that does delete them after a certain amount of time. So let's say we wanted to visit logs again and do historical analysis months later. It might be too late. And that's a shame because logs are valuable and cheap to store. So small apps should definitely be capturing them. So now let's talk about syslog and the logging standards on most Unix-based systems, and essentially how it works and how that data is recorded and why and when it's deleted. So syslog, it's the dominant logging protocol for Unix systems, officially as of 2009. And here is how it looks on a standalone machine. So a system, a service daemon generates log messages. A syslog daemon captures those log messages and can process them. And what it can do is it can record it to a log file like we talked about, or forward them to an offsite location. So the syslog daemon, it can receive and process these logs. And there's also various alternatives to the syslog daemon that's built on top with more features like Rsyslog or syslog ng. Crato itself uses Rsyslog. But let's say that it's recorded to a file system. What's the process that that controls its deletion? Well, log rotate manages compressing, archiving, and removing of log files, and that's typically determined by whether the log reaches a certain size or after a certain amount of days passes, which you can configure by your own choice. So for a small application, how does it typically look when you have a distributed system and you want to visit your logs? So you have to visit each component individually to understand what happened, correlate events, and do analysis. And this is a bit cumbersome, but luckily syslog does provide a way for us to make this a lot easier. So with syslog, we talked about how the syslog daemon can forward it to an offsite location. And what we can do is we can forward logs to a central log server. And we can forward all these logs from these multiple components for a central log server, and this creates a unified stream, a single point of observability, which is really awesome and valuable, and of course, a lot easier and reliable. So just makes everything easier for analysis. And this is how it looks now. So this is the idea behind centralized log management. So centralized log management, it's just, a central location makes everything easier. And we have these various system components. They're forwarding logs to the central server. And now we can just read them all from runstream and do analysis from there. So that's pretty awesome. So that's why centralized log management is important. And for a centralized for a small and growing web application that wants to manage their logs and do centralized log management, let's go and talk about what solutions exist in the space currently. So current centralized logging solutions, they come in 3 categories. We have LAS, logging as a service, which is where the paid solutions exist, typically cloud-based. You can do it yourself and build your own centralized log management system from scratch. There's also open source solutions like the Elastic Stack and Graylog. But let's go and cover each of these. So logging as a service, full service log management, it comes in 5 key functions. Log collection, ingestion to storage, which provides search and analysis capabilities, and then there's monitoring and visualization. The most popular products exist here. What are the trade-offs here? It's really easy to work with these systems. You just got to configure your components to forward the logs to them. They'll take care of the rest. Technical support if something goes wrong, and they have a rich feature set. But of course, obvious cons, the cost, it can get expensive depending on how much data that they're ingesting, how many people are using the system, and other factors. You might become vulnerable to vendor lock-in. And there's a loss of data ownership because you're sending logs which might contain sensitive information about your users to a third party. So for those people, you can do it yourself. Another alternative is doing it yourself and building your own system from scratch. And what's involved in that? We can simplify the 5 key functions we just talked about into 4 phases of log management. So there's the log collection. We then forward it to a central server for processing and aggregation. We might then send it to an ingestion service, which we would then pick up the data from to write it to some type of storage service, and then connect it to a monitoring and visualization tool for more easy visualization of our data. So how does that look? So log collection, it starts, like we talked about, on an individual machine, and log collector agent is just another way to refer to a syslog daemon or its alternative. So how that looks is, we might just place our syslog here and at the central log server, and the our syslog daemon forwards it to a central log server and can also do processing, like structuring the data if we wanted into a format like JSON. You can put something else like syslog-ng. So there's no shortage of alternatives here. So log collection, you've got the logs, you forward it to a central log server, you got your single point of observability. And then what's next? You want to send it to an ingestion service and also get it to storage. Why do you need an ingestion service? Why can't you just send it directly from the the central log server to storage? Well, you could if the data volume is low enough. But the benefit of an ingestion service, it helps you queue the data, you can batch it and write it more efficiently, and it helps you decouple the process. Also, if you're going to be writing to multiple storage systems, it allows you to scale more efficiently and a lot more easily. So that's what's happening there. And then finally, there's monitoring and visualization. You would just connect that to your storage system, depending on which one you use. So there's no shortage of options here. These are just various options that you might use to build your own centralized log management system, but by no means they're exhaustive. There's log collectors here, there's streaming services, there's storage services, and also monitoring and visualization services. But yeah, no means exhaustive. So trade-offs, built to exact needs. You control the storage on your own terms. and maintain high control of data by self-hosting it, but it's complex. So that's why we also have open source log management tools. So you can install, configure, and host your own pre-designed system. We have the Elastic Stack, which essentially Elastic is a company, and it provides a collection of open source tools that are designed to work well together, including Elasticsearch, Logstash, and Kibana, which fulfill the functions that we talked about as part of a centralized log management system. Same thing with Graylog. It's a central log server, provides a web interface for system configuration and also just visualization. So this is where we want Crato to exist. What are the trade-offs here? So you maintain a high data ownership and control. They're well documented and tested, easy to use generally, and there's lots of plugins because it's open source. Cons are it's one size fits all, and the maintenance and scaling for it can be costly, and it can get complex quickly if the configuration changes, and you have to figure that out on your own. So yeah, summary of the 3 solutions: logging as a service. They're easy to use, but can get expensive, and there's low data ownership as part of storing logs on a third party. Open source solutions, you have high data ownership, but there's still some complexity with self-hosting it and scaling it. And doing it yourself, yeah, there's a high amount of data ownership as well, but can be pretty complex as well, and can get costly as well in terms of developer time. So now we're ready to talk about Crato and where exactly it fits in within the open source solutions. So when evaluating between ownership and complexity, where we want Crato to exist is at this level of high data ownership, along with the other open source solutions like Graylog and Elastic Stack, and also doing it yourself. And we want it to be easier to use than them, but it's hard to compete with the ease of use of logging as a service tools. So some of the design goals behind it, we wanted it to be open source. We wanted it to be easier to deploy. We wanted to avoid vendor lock-in, lightweight, manage the typical small applications data log volume, and most importantly, save logs now. You decide if, when, how to parse. So the architecture, what's involved in the Crato framework. So on the one side, there's of course the clients, the system components that are forwarding the logs. And then we have on the right side where the Crato Core framework starts, where the Crato server exists. So we have our syslog central server, expose ports to receive log data and provide that single point of observation, and also process the log data into a format like JSON and also text. And then we want to produce it from our syslog to Kafka for buffering and queuing. We have a Node.JS consumer that picks it up from Kafka and then writes it to InfluxDB and AWS S3. So yeah, configuring the Crato client. So talked about the Crato client. We provide a bash command line application to essentially forward logs from your system components into the central log server. So this configuration file, you specify here the log files that you want to capture. You can organize them by tags, and then the severity levels tell us how verbose you want the log messages to be. And then, of course, you have the public IP address of where the central log server, where the Crato Core framework exists to centralize, to aggregate those logs, and then also do the rest of capturing and storing and processing them. So how do you use the Crato client? So yeah, it's pretty simple. You just run the app, and there's a couple flags. C for config, and then there's also S to stop the configuration if you want to stop the system component from transporting logs, and then other command line flags for help or resuming if you stopped it. So yeah, the Crato Core server-side framework, we just talked about this. So how how can you use it? So there's a single command. We created our own custom command line interface for it. And the first command is just installing Kafka. So it's not typically as quick as this. I just, for the purposes of this GIF, I installed all the dependencies and stuff. Yeah, 2 commands. Install Kafka, so it sets up Kafka, and then sets up the topics, which is how data is organized. And then there's a Crato deploy command to actually deploy the Rsyslog central server, actually deploy the Kafka system with all the nodes again, and then also the InfluxDB and Node.JS consumer application. So yeah, let's talk about the implementation. Yeah, we just talked about how we collect and aggregate it client side, then we ship it to our core Crato framework. Now let's talk about how we get it to Kafka. So the central server sends logs via a Kafka module, which acts as a producer, and it sends logs in 2 formats: the raw text, and also it structures it into JSON. And then the benefit of using Kafka is we have a Node.js consumer app, and with Kafka, we can provide exactly once delivery, which is pretty clutch. And our consumers can manage the flow and manage the flow to suit the endpoint's needs. So we can, if there's a high log volume, we can control that. And that's the benefit of that. And also, we provide batching and queuing. And the consumer saves the log to a JSON file. It sends it to AWS S3 for long-term storage. And then also, it sends incoming messages to InfluxDB for more immediate access to recent log messages, because sometimes you can't just wait a couple hours in order to grab all your log files. You need access to that data immediately. So yeah, those are the dual storage needs: long-term storage and also immediate access. And yeah, that's the core Crato framework. So yeah, we provide a Crato Client application and then a server-side Crato Core framework. And we use Docker to essentially set up everything, containerize all our services, isolate them if something goes wrong. And we also have built the Crato command line interface to abstract over it. So it was really fun to work with this and use this technology. Feature plans, we want to provide visualization integration, which is something a lot of LAS solutions do really well, and it's really cool. And then we want to have security option for LAN and communication via TLS, and then compression option for large messages. But yeah, thank you for your time today. Yeah, that's my email. If you want to talk to me about this, feel free to send me an email. That's the Crato GitHub, so feel free to, there's different repos for the Crato Client, Crato Core, and some support scripts. So feel free to check it out. Feel free to fork it. Feel free to pull it. By the way, I'm also on the job button, so if you want to talk to me about that, feel free to do so. And thank you for your time today.